In this video, we're going to continue to look at Turbo Intruder, the extension for Burp Suite, right after this automatic backup of my project. In particular, we're going to look at fine-tuning Turbo Intruder in order to capture only the responses that we're actually interested in. So here I have a very uninteresting target to look at, but it will be fine for the purposes of this demonstration. This is looking at Portswigger's Gin and Juice Shop once again. And in this case, we're making a very simple request to grab an image from the application. And I have a very simple question. What are the set of valid images that exist here, right? Can we enumerate more of these? And ordinarily, this would be a very simple task for, regular Intruder. You wouldn't typically pull out Turbo Intruder for this, but it'll be a great example for our purposes. So I'm going to right-click in my request, and I'm going to open up Turbo Intruder by sending the request to it. And I'm just going to start with the basic.py example here that comes with Turbo Intruder. And we're just going to set up a very, very simple attack. So first, I'm going to replace the image number here with our insertion point for our payloads. And I'm going to change the payloads. The default here for basic.py comes with a word list. We're not going to use a word list. You can use a word list. You can use, you can generate things. We're just going to enumerate through the numbers, 0 to 9. So what I'm going to do is I'm going to say for I in, and I'm just going to use Python's range function. Range 10 is what we want. We are going to queue up a request with I as our payload in our payload insertion position, which of course is denoted in vanilla Turbo Intruder with the %s symbol. And what we're really interested in here for our example for this video is how the responses are handled, right? How do we determine the responses coming back from the application, which ones are of interest to us? And in general, this is a problem that you cannot solve with, or at least has not been solved with automation, right? There is no perfect way to determine in a general sense what are interesting responses that tell us that something we're looking for exists here, or we've triggered some type of behavior that we might want to explore further. Doing it automatically and for every application, for every situation, it's impossible to come up with some way to do that very well across all of those cases. So what you really want to do as a precursor to even launching an attack like this is take a little bit of time to try and understand your application, how it works, what you're going to expect to see. And actually, we're going to skip that step because we're going to see in the responses that come back from this attack how we can better fine-tune this. And actually, to make this attack even simpler, you'll see that there is some handling logic already where it's saying if the request status is not equal to a 404, then we're interested in it, and then we're going to add it to our table. But I'm actually going to comment off that conditional, and I'm just going to say, for every response that we see, we're going to add it to our table. So we're going to take everything, which again, you wouldn't want to do in a practical Turbo Intruder attack. You'd want to take some time to fine tune it to make sure you're only getting the responses that you want, so you don't, blow up your burp. But in this case, we're only making 10 requests anyways. So let's run the attack. Let's see what happens. So I click attack, and off we go. And we get a number of responses. As you can see, we have 10 request response pairs, and we captured all of those. And you can immediately see that there are some differences in the responses, right? There are some short responses that do issue 404 status codes, and there are also some longer responses that clearly are valid images, and these return 200 status codes. So if we're conducting a much larger attack, what we'd want to do is only return what we're interested in, right? So these 404s, we don't want to see them. And in our cases, this is very simple, right? We can actually just go back and uncomment the default conditional that's in here. So if the request status is not equal to the 404, then we will add it to our table. And if I run that attack again, then we are going to populate that table only with responses that have a 200 status code. And that's going to work just like that. In a lot of different scenarios, you can probably just use the status code for many attacks. But obviously, depending on the attack you're doing, depending on the application, there are going to be also many situations where you're going to want to fine tune that handling logic to be more precise and to, sometimes just, filtering out 404s is not going to cut it, right? So what else is available to us in order to filter responses? Well, obviously we can just change this number here. We could change it to a 400. So you could say, for any 400 attacks, don't return those. And so now we get those 404s back. You could say, you could match only a specific response code. So in this case, the code 200. You could even do a greater than or less than comparison here as a quick way to filter at a certain point. But you also have different attributes available for that request object that comes in. So conveniently in this example basic.py that comes with Turbo Intruder, it tells us with this comment, James Kettle has taken the time to leave some handy documentation right in the example. He tells us that what is available to us is the status code, the word count of the response, the length of the response, and the response of the response. And this is probably, this last one here is probably the most interesting. I think you can probably infer what the length and word count are and how those are going to work and how you can work with those in Python. But the response is probably the most interesting because that's just the string response, the response data that comes back. So what we can do if we want to is we can operate directly on that string data. So we could actually change that. We could make this logic effectively the same, but operate on the response string instead. So in this case, if I'm going to modify this a little bit, if 404 not in request or rec.response, then we will add it to the table. So in this case, what we're doing is we're checking whether we're basically checking for string match, right? We're saying, is 404 the string in our response? And if not, then we want to add it to the table. And so we run our attack, and look at that. We get our 200 responses as we expect. But this approach here probably has, or I should say, I shouldn't say probably, I should say might. I haven't actually, profiled these. It might have, a little bit more overhead than just using the status attribute to compare. And you could obviously imagine different scenarios where you're working with the response string. Maybe you're running complex regular expressions to match different things, where the computational load is going to increase quite a bit beyond a very simple comparison against the status attribute. And that's something that is important to keep in mind, because as you're running, typically when you're running Turbo Intruder, it's going to be in scenarios where you want to send many, many requests. And so, the scale of requests is going to put that increased computational burden on your system. And so you want to think about those little ways, not just in the way that you set up your engine to send requests, but also in the way that your system is performing the logic in the handling of those responses. You want to think up, the various ways in which this logic is going to impact performance, and you might be able to fine tune it to the simplest possible approach for your situation. Although practically, probably most things that you're doing, like running a simple match of a string, is not going to be anything that is really noticeable. But I haven't profiled it significantly, so I haven't seen how the performance behaves with complex logic over very, very large attacks. But there are examples that may be a little bit slower, and you can find some of those examples available in just base Turbo Intruder. For example, there is an output to file example, and in this case, not only are we adding our request response pairs to the table, but there's also logic to write that data to a file. And probably this is going to have quite a bit more overhead than simply comparing the status code and adding it to the table. But maybe that is a use case that you need. And so you can use Python to do all kinds of wild things in your response handling. And you can write things to a file. You can trigger other functionality. There's a lot you can do. But you may impact your performance. So that's what I wanted to say about that. And I won't go any further into what you can do with the actual request attributes, like the response, for example. You can learn Python if you don't know it and figure out the different operations that you can do. But I will show you the other built-in mechanisms within Turbo Intruder that will allow us to filter and handle our responses. One thing to keep in mind too that I mentioned in a previous video, but I'll also mention now, adding our request response pairs to the table, like this operation here, James Kettle noted that there's also a fair bit of overhead with this as well. So it really does help you from an efficiency point of view, from a performance point of view, to fine-tune your logic here in order to capture only the responses that you're really interested in. So dealing with these attributes is one way to do this filtering. Another way is actually by using the built-in interesting filter. And so let's play with this right now. But before we play with it, I'm going to explain a little bit how it works. There's a little bit of information available in some of the documentation that James Kettle has made for the tool, like the original article for the tool. But the way that this functionality works and the inspiration for it actually comes from his work with another tool known as /powered scanner. And I will do a video going over, hopefully briefly, that tool sometime in the near future. But right now, I'm just going to pop over to my target tab real quick, because you'll see that I have actually installed that extension, /powered scanner. I've used it to scan gin and juice shop, and I have a result from that tool right here. And the reason why I wanted to show this is because it shows some of the metrics or some of the attributes that this the utility functionality uses in order to determine whether a particular response is interesting. So as you can see here, the way that this tool works, if you haven't seen it before, is it prints out these, it sends a number of payloads to the application as any automated scanner, and it prints out this table here. So this is a single table here, right? It shows us the attribute, and then it shows us the two payloads, and it shows us the value for that attribute when submitting those two payloads, right? So when submitting this payload, these, well, I can't really kind of select that column, but everything below it is the attribute value that corresponds to where that payload aligns with that attribute, right? So the status code here is 500, but when submitting this payload, the status code was 200. So the way that this tool works and the way that Turbo Intruder utilizes the same utilities is by sending a number of initial requests to look at the natural variation in responses when you're sending payloads that aren't of any interest or value to you, right? You're sending basically junk data, and you're saying, when I'm sending something that shouldn't trigger any kind of interesting behavior in the application, how does the application actually, respond in that scenario? Does it give very different responses that is going to be very noisy for a scanner to understand when looking at those? Or, is it giving the same response every time? So it's very clear that we can look at something simple like a status code or the length of a response to determine whether, one response is potentially interesting. And so there is an initial component of training the, I want to say classifier, but it's not using machine learning, but I think maybe it's helpful to kind of think about it like that. There's kind of an initial training component to it where it looks at, what attributes here change naturally. And then when it runs the attack, it looks for changes in other attributes, right? When you're actually running the attack, are there other attributes that it didn't expect to change that are changing? And conveniently with /powered scanner, it prints out the table of some of these differences in attributes, which is very handy because then we can see how the tool came to the decision that it saw two different responses and how it determined those responses are essentially different. We don't get that same information from Turbo Intruder, but nevertheless, we can still use the tool to try and capture interesting responses. I wouldn't necessarily rely on it all the time, but it might be something that is very helpful in setting up attacks, especially where you're not certain of what the outcome is supposed to be or what you're trying to do, right? In our case, it's very easy because we can go to repeater, we can look at this request to get images, we can send a known image, we can send an obviously non-existent image, and when I send that, we get 404 not found, right? So we very clearly know the behavior of the application when we have a request that gets what we want, which is an image, and we know the behavior when there is no image. It's very simple, but you might not always know that. You might be essentially fuzzing a web application and asking the question, what happens when I send random data? Is there some kind of weird behavior that I can trigger? And then you're effectively looking for a unique response in a set of many responses that may have natural variations in them. Okay, so that explains how it works. Now let's finally set up an attack here, and I actually need to kind of recreate what we've already done. So basically what I'm going to do here is I'm going to run the same attack, but what I'm going to do is I'm going to change the filtering here to just be this. We only want what is interesting. Again, this specific attack that we're going to be running is perhaps not a great example for a scenario where you would do this to some practical effect. But nevertheless, it can hopefully illustrate how the functionality works. So here I'm going to queue up some more requests. And if you look at the built-in examples in Turbo Intruder, I think some of them use this function here, which I'm going to use. And actually, I'm gonna change this range. I'm just gonna have it be from be 4 to 5. So you'll see that this function is used, and I was a little confused for a moment because I didn't recognize it as a built-in method. But if you go to the documentation, if you search this in Turbo Intruder's GitHub, you will find the code for it. So there are a number of built-in utility functions in this script environment.py, and one of those is this random string, obviously, function that takes 2 parameters. One is a length. Of course, there are defaults, right? So we don't even need to send it parameters, and also whether to include digits in there. And you can go and look at how that works if you're really interested. But basically, I'm just creating some, a little bit of random input. And the effect of this is just going to be to retrieve or to try to retrieve non-existent images. So it's not that interesting in our example. What Burp should get is those 404 responses when running these. And actually, I can probably give it some more data there just in case it needs to build up its data set a little bit more. And then we set this third parameter, learn, which I've set to 1. I do need to do a little bit more research into how this particular parameter operates. I think that you can create different sets of learning payloads that are intended to produce different similar responses, but I haven't manipulated it too much. Hey, maybe go give it a try and leave a comment with how it works if you're familiar with it. But for now, we're just going to use this very simple example anyways, where we set learn equal to 1, because this is these are our learning payloads, and then we're queuing up our actual payloads. And then finally, we have our response handling, where if it's interesting, then we're going to add that response to the table. So interesting here is a Boolean that comes in, so it's very simple to just say, hey, did Turbo Intruder determine that the response is interesting? If so, add it to the table. And I haven't run this attack yet, so I'm going to run it now, and hopefully we get what we want. And look at that. It's a success. So we get only the images with the status code 200 in the response. And the reason that worked, of course, is because all of these initial requests would have been 404s. And if you want me to demonstrate that, what we can do is I can comment off this interesting filter, and I can remove the training component of this to just make them regular items in our queue. I launch the attack, and now what we're going to get is those random strings that obviously do not correspond to images that exist on the web server. As you can see, all of those result in a 404 not found. So those initial payloads, or those initial responses, Turbo Intruder used to look at the various attributes of those responses and say, okay, well, we're only going to show another response if it's if other attributes differ other than the ones that differ naturally. And of course, because when we follow that up with sending requests for actually existing images, they have much greater length, and they have a 200 status code. And there might be other differences as well that are caught by that analysis process. So that's how that works. And as I mentioned, probably the most useful scenario is where you're fuzzing. You're not really sure what you're looking for. You just want to see if you can produce an interesting behavior from the application. So it's quite a handy thing to have. But now we're going to look at one final way to filter the responses and build our table with the request and response pairs that we're interested in. And I'm going to remove entirely that interesting component, because what we're going to do now is just work with decorators. So this is another function that, or another feature that James Kettle has conveniently built into Turbo Intruder, and also conveniently decorated, or documented, not decorated. In this, if you go to the GitHub page for Turbo Intruder, you can find the decorators.md file, and it has the documentation and handy examples. So this functionality is so well documented, I feel like I don't even need to show actual examples. But basically what you do is you use these Python decorators, and you apply them to your they handle response function in your attack. And so just looking at this example, right, this decorator is called match status. And if that's not apparent what that does, if it's not an intuitive name to you, you can actually scroll down to the handy table with descriptions. Match status matches responses with one or more specified status codes, right? So in this case, it's going to match all of the responses with a 200 and 204 status code. And of course, the documentation also tells us that right here. And I don't feel the need to necessarily go through each of these and show you how they work, but you know what? I'll show you at least one. We'll use this one just to prove that it works. And we'll use it geared towards our example, which is very simple. Again, we don't have 204 responses here. We just have 200 responses. So we're going to run the same attack. We're not going to use the interesting filter. We're not going to look at the request status attribute specifically or match the response. We are going to use this decorator. We're going to run the attack. And wouldn't you know it, we get the expected result where it only returns to us and puts in our table the responses with the status code 200. Isn't that great? But I will go back here and, as one final note, point out a couple of interesting decorators that I've actually never used. And it was only when reviewing the available decorators for this video that I thought, oh, that's kind of interesting. Maybe I'll use this at some point. So the interesting decorators are these ones here that also conveniently have their own section describing how they work. So there's really not much need for this video. It's all documented right here so well for you, but I'll describe it anyways. So let's look at unique size, for example. So what this does is it takes the size of every response, and then what it does is it only fills the results table with n instances of responses with that size. So if your instances is set to 1, it only gives you once a response comes in with that size, it's only going to fill that table once, right? So you're only going to see it once. So every other response with that same size you won't see, but you will capture responses with other sizes. Of course, you'll only capture one of each size, right? And so I thought that could be interesting to, if you're conducting, if you don't want to rely on the magic of the interesting filter and you're conducting some type of attack where you're just trying to provoke some type of interesting server or application behavior and you're sending a lot of traffic to it, it might be a really quick way to filter out different types of responses without even a pre-training where you kind of have an expectation of things that you want to exclude. So it might be something that you that is worthwhile trying at some point. I've never used it. I'd like to use it at some point in the future. So I'll have to keep that in mind. But as of now, it's an interesting decorator that is available. And as with all of these other decorators, which probably a lot of these are a lot more practical, because I think with most Turbo Intruder attacks, you probably have an idea of what you're looking for and trying to accomplish. And that's always the best way to do these attacks, right? Where you know what to expect, you can really fine tune your response handling, and therefore you're running an efficient attack that is predictable in its outcome. But lots of options available here. It's a very flexible tool, which of course is what motivated me to make some videos on it. I might have some more videos on Turbo Intruder, but for now, this is how you filter responses using Turbo Intruder. Thanks for watching.